I'm Pat Hindle with Microwave Journal, and I'm here at Mobile World Congress 2017, and I'm sitting with Bami Bastani. You're the Senior Vice President of the RF Business Unit at GlobalFoundries. Welcome.
Thank you, Pat. Glad to be here.
So we've seen a lot of things going on in the RF industry, changing very quickly, a lot of those being enabled by semiconductor technologies. What kind of trends are you seeing in the RF area?
Well, if you're in the RF, it's wonderful to see how this whole ecosystem and the environment is developing. Bottom line is that within our lives, I see everything is going to have a radio in it. And every radio needs semiconductors. Connectivity, wireless connectivity, is driving the behaviors, the social structure, everything. We love to be part of that. Of course, that means that now your complexity of the technology is escalating. We see moving from LTE to advanced LTE to 5G to sub-6 gig to millimeter wave, and all of that creates absolutely the environment that everybody wants to be part of it. And at GlobalFoundries, of course, we are the leaders in the field. We are enjoying that leadership, and we're contributing to that.
And so the talk of Mobile World Congress is, of course, 5G and IoT. How are your platforms enabling low power and low cost but high performance, that balance?
So what we have done let's talk about 5G and millimeter wave. First of all, we have technologies for sub-6, like when you talk about 3.5 gig for small cells, perfectly fit to our generation of 7SW and the upcoming 8SW technologies. From 7SW, which was also a 200 millimeter technology, we have moved to 300 millimeter technology. So it's the first time that we see wafers are also scaling, and the foundries like GlobalFoundries are playing a major role in leading the way. Now, for the above 6, moving to millimeter waves, 28, 39, 60, 77, 90, and then the sky is the limit. We are innovating with technologies which are enabled by our advanced technologies like 45 RF SOI. We'll talk about that a little bit later, because in the news that was one of the things that we talked about. 45 RF SOI uses our most advanced technologies, but it's tailored to the millimeter wave. And so I'd like to show you two things. Number one is that you move to 300 millimeter. Now this is the digital wafer scale. And I like to say GlobalFoundries, we are a leader in this space, not only in terms of technology performance, but also ability to scale the technology in terms of high volume production. And then also you see the millimeter wave, like you have heard the announcements by Anokiwave. This is one of the highest integrated phased array examples of a client, enabled again by our technologies. So we're excited about it. With the IoT, our 22FDX, which is giving you the lowest current and highest level of integration. So compared to when you need low power, our 22FDX is capable for IoT to integrate all the way from what used to be called RF front ends, all the way to the digital section with transceiver and everything between. So I'm very glad to say at GlobalFoundries, our technologies span not just the front end modules, not just baseband or a transceiver, but in IoT where you need low cost, high level of integration, and then moderately low powers, 22FDX is the solution. At the high end where you need highly integrated baseband, you need transceivers, LNAs are moving to FEMs. We've got 7 nanometer for integration and performance. We've got 14 nanometer FinFETs. We've got technology for transceivers, and of course our 7SW, 8SW, 45 RF SOI, depending on the power level and then depending on the level of integration within the FEM.
So you have a really wide variety, but let's talk about the announcement. Exciting news. Can you tell us more about the new RF 45 nanometer process?
Yes, historically we're used to saying when the digital world moves, then that old 200 millimeter fab becomes your RF fab. Well, and then that's a perfect fit. It's a low cost. It is fully depreciated. But generally, those technologies were around like 130 nanometer, 180 nanometer, and that regime. Our announcements takes that game into 45 nanometer. 45 RF SOI is based on proven server and ASIC technologies that we were running at East Fishkill for many years. So it has a very strong unit process and digital backbone in terms of delivering performance. We have taken that, tailored it to very strong high frequency response needed, like FD, Fmax over 300 gigahertz. We have added the back end of the line interconnects, so you can do your inductors, thick metals, thick copper, thick dielectrics, which makes a process very RF friendly. We have PDKs behind it that makes the design easy. You know, so many cycles of learning goes through when your simulation doesn't match your real circuits. And then it's in many RF worlds, it's given that I'm going to run multiple iterations. Well, one of our value adds, one of our strengths is with that IBM technology that we brought into GlobalFoundries, the whole accuracy of simulations, the whole PDK predictability of the designs is at a higher level. We call it best in class. So with the 45 RF SOI, you can get your number of iterations down. You can address the millimeter wave world and the 5G world with more predictability and use what is considered the most state-of-the-art technologies that does your switches, your LNAs, your power amplifiers in a fully integrated fashion.
Very good. I think that's really going to enable the RF world to make it step into the millimeter wave region, and high integration will reduce costs. So that's an exciting opportunity, and we thank you for joining us today.
Pleasure to be here. Thank you.